one was not so bad. This is like obviously filling in a T-chart. When it comes time for test on this, you will also get given a T-chart. If you weren't, like so on the web assign, it doesn't really specifically state, then you can just choose numbers to plug in. I pick these just because it gives you a like range of negative to positive. But if it's not giving you the domain restriction, then anything can get plugged in. So if I plug in the -2 into the x, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And then I plug it in for y. So I get -2 minus 2, which is -4. -1 minus 2, -3. 0 minus 2, -2. 1 minus 2, -1. And 2 minus 2, which is 0. And then what I'm going to plot is the coordinate point that is made from the x and the y. So 4, -4, 1, -3, 0, -2, 1, -1, and 4, 0. And I get 4, -4, 1, -3, 0, -2, 1, -1, and 4, 0. So this looks like a parabola turned on its side. And you have to make sure to add what? The arrows. Good. The orientation goes away from the first point we plotted and towards the last point we plotted if you did it in the order of increasing t. Questions on that one? Not so bad, right? Okay, then came eliminating the parameter. So eliminating the parameter means get rid of t. So I'm going to look at these two equations, and I've got to isolate t. Both of them have a coefficient, so they're both like, you're going to have to move something and then divide. So let's pick one. Which one you want to solve for, x or y? Y. Okay, so we're going to subtract the 1. Y minus 1 equals 2t. And then I'm going to divide both sides by 2. Y minus 1 over 2. And you can leave it like that, or you can separate it out. You can make it y over 2 and -1/2. It doesn't matter. We're plugging it in anyways. So it doesn't matter how you plug it in. So now I'm going to take this guy and plug it into the other equation in place of the t. So I get x equals 3 times y minus 1 over 2 minus 2. If it had just said eliminate the t, you've done it. But because we have to graph this, we have to figure out what kind of graph it is. I'm going to keep going. So I'm going to distribute the 3, and well, I'm going to separate out actually. The y over 2 minus 1/2 minus 2. I'm going to distribute the 3. Actually, I want to get rid of that 3 eventually anyways. So you could add the 2 and divide by 3, or you could distribute the 3. So I'd get 3y over 2 minus 3/2 minus 2. What kind of graph do you think this is eventually going to be? What's true about both the powers on x and y? It's linear because they're both raised to the first power. So I want to get this in a slope-intercept form. So it's messy right now, but eventually I want to get it into y equals mx plus b so I could graph it. So this 2 changes to 4 over 2. I get x equals -3/2 y. And then minus 3/2 minus 4/2 is -7/2. I want to get it to y equals mx plus b. So I'm going to multiply everything by 2 to get rid of those fractions. 2x equals 3y minus 7. I'm going to add the 7. 3y would equal 2x plus 7. And last thing is divide by 3. And I get y equals 2/3 x plus 7/3. So this is rectangular form. We eliminated the t, and we got what will be an approximation of this parametric function. When I go to my graph, 7/3 is the same thing as 2 1/3. So I'm going to go to 2 and a little bit past it, plot that 2 1/3 as my b. And then my slope is 2/3. So I go up 2 to the right 3, or I could go down 2 and to the left 3. Either way, it forms the line. This does not have the orientations, right? Because this is an approximation. We lose which direction those arrows would go, so we put arrows at the end because it's a line. Questions? So the solving end of this was messy, but the plugging in we understand, right?
Why are they going in 2 directions?
Because it's just a line now. It's an approximation of what it is, right? So we took what would have been a parametric function and we made it turn into a line.
And how do you know, because on the homework there was a question where you had to pick a graph and some were full parabolas and some were like half parabolas?
Is it an eliminate the were you eliminating the parameter or were you graphing the parametric?
Like, were you trying to find the equation? Or?
Like, did you have a t-chart? Like, did you bring in a t-chart? Like, where you plug in -2? So the questions say graph the parametric function. Then it's not a full parabola if you have a restriction.
Okay.
If it says like this, you're eliminating the parameter and you're graphing. Now it's going to be your true form. So if it's a line, it extends in both directions. If it's a parabola, the arrows point in both directions. Yeah.
Can I show you the homework stuff? Just like.
Yeah.
Okay.
Yeah.
Now or.
Wait till we're done, but go and take a screenshot of it now if you want. All right, last question or last type of question is find the set of parametric equations to represent the graph of y equals 4 minus 7x using the parameters. So remember I said these are kind of confusing because they build two questions into one. I want it to be consistent with like what you see in WebAssign. But really this is two questions. This is find a set of parametric equations to represent the graph of y equals 4 minus 7x using x equals t. So those are your two functions. One is rectangular because it doesn't have a t. One's parametric and I need to make two parametric. So the one that already has the t in it, I'm going to solve for the other variable, which I did. That's one part of it. And then I'm going to take that and plug it in place of the variable that didn't have the t. So y would equal 4 minus 7t. And that's the other half of the parametric equations. Then B, same set of instructions, but this time the second equation is t equals 2 minus x. So my first equation is still y equals 4 minus 7x. Now I'm using these two. And again, one of them has a t, one of them doesn't. The one that has the t, we need to solve for the other variable that's with it. The one that has the t is the bottom and has an x with it. So I'm going to solve for x. You can either subtract 2 and then divide by -1 or multiply by -1, or I could have moved the x, then moved the t. Either way, same result. So that is telling you x equals -t plus 2 or x equals 2 minus t. You could use either one of those. And then I have to take that and plug it into the equation that didn't have the t. So this is going in the place of this x. So y equals 4 minus 7 times 2 minus t. 4 minus 14 minus or plus 7t. And y equals, and again, order doesn't matter. I could do 7t minus 10, or I could do -10 plus 7t. That's your second equation for the parametric equations. The other one was x equals 2 minus t. So these are the two. Questions? Good on parametric. Yes. Heads, some heads on. Yes, we're good. Okay. All right. So we're going to move into the good and the bad is that it's completely different than what we just did. So if you enjoyed yesterday, sorry. If you didn't enjoy yesterday, congratulations. We're moving on. Okay. This is called polar coordinates, and this leads directly into 9-6. So 9-6 and 9-5 go close, like go hand in hand. You have to have mastered 9-5 before we get to 9-6, or it's going to get super confusing, okay? Today, we're going to graph something called polar coordinates. So everything we've done up to this point, rectangular coordinates, were like x's and y's, and we plot them on a coordinate grid. We've even done complex, like we've done a plus bi, and we put it on a complex coordinate grid. What we're going to do from this section and the next is put it on what's called a polar coordinate system. So to form the polar coordinate system in the plane, there's a fixed point. In this case, it's called O, which is the pole, or which is also called the origin, and construct from O an initial ray called a polar axis. So what this will look like is a completely new polar coordinate grid. Actually, let me just pull in a picture of it. A completely new thing called a polar coordinate system. Which looks like this. I actually put this picture on your 9-5 homework if you wanted to grab it, the exact picture, but also if you just go to Safari and you search for polar coordinate system. This is what it looks like, okay? It's like a bullseye shaped. And what it's formed by is the x-axis and the y-axis. The x-axis is now called the polar axis. The y-axis is the pi/2 axis. And it has those rings. Each ring represents one radius. So our unit circle would live inside that first circle. All of our unit circle angles would live there. All of the coordinate points that you know from your unit circle angles would be the endpoints of those. What happens is we just continue to extend this out. Each ring is a new radius, okay? Don't let it overwhelm you yet, okay? All we're doing is plotting a point. So we have to find what's called a directed angle. The angle are the angles you know. Pi over 6, pi over 4, pi over 3. And then your radius tells you which ring to go to along that line. So if my radius was 4 and my angle was pi over 6, I'd go to where pi over 6 is. I'd go to the fourth ring and I plot a point. And these are just coordinate points for now, okay? So you find it's got two parts. The radius comes first and the angle comes second. You find the angle and then you go to that ring along the angle to plot your point, okay? So the format for them, and again, these are called polar coordinates, is r theta. This is how it will be written. For example, like the one we just did, what I say, 4 pi over 6 is how this would look. The 4 represents the radius, which means which number circle you're going to, which ring you're going to. And the theta is the angle along the angle in which you go along that line. It's called a directed angle, but it's just an angle. So here we go. I'm going to actually pause, go to the assignment, and grab that. All right, so we're going to plot it. The first one is 2 pi over 3. Pi over 3 is already marked, right? Pi over 3 is here. I'm going to go out 2 rings on that. 1, 2, plot a point. And that is 2 pi over 3. B, 3 and negative pi over 6. So what happens when my angle is negative? You have 2 options, right? You can either find the coterminal, like add 2 pi, find the coterminal, or what? What's that hamburger trick? Find where it's positive. Positive pi over 6 is here. Fold it like a hamburger. Where it overlaps is where it's negative, which is here. And then my r is 3. Good so far? Yes? Okay. You do A, and then I'll help you with B, but do A first. All right, 11 pi over 6 is in that fourth quadrant. 3 would be the third ring. So that's 3, 11 pi over 6. Good? Yes? All right, so now what changes if the r is negative, okay, is that instead of going towards the angle that it is, we go the opposite direction. So if it said negative 3, 11 pi over 6, 11 pi over 6 is normally here, and normally we go in that direction. But instead, we literally switch it and go the other way. So from the pole, we go 3 in the other direction, but along the same ray. And that would be negative 3, 11 pi over 6. So if the r is negative, we go away from the angle that same amount of rings. Still good? Yes? Okay. So now how would we find additional points? So some of these questions will say is plot the original point and then find 3 additional polar representations of the same angle. It means give it the same location but different names, okay? And you have 2 options to do this. The first is do not change the r. So we're going to leave r with the same sign as my original. But take your angle and add or subtract even multiples of pi. This is a coterminal angle, right? If I plot a point here and I add pi to it, or 2 pi to it, it's going back to the same spot. If I were to subtract 2 pi from it, it goes back to the same spot. So we're saying leave the r the same, add and subtract multiples of 2 pi. So it could be 2 pi, it could be 4 pi, it could be 6 pi. There's an unlimited amount of names we can give this. The other option is change the r, and actually this is just odd multiples is what that means. Change the sign on the r. So if I had started with, let's say this was a 2 pi over 4, I would change it to negative 2 pi over 4, negative 2, but then I want to get halfway around my circle, because if I start halfway around the circle and I make it negative, it's going to where we are. So I would change the sign on the r, and then add or subtract odd multiples of pi, meaning add pi, and I'd get 5 pi over 4, or subtract pi, and I'd get negative 3 pi over 4. These have the same location. Now, the other thing this says is the pole is represented by 0 theta. If my radius is 0, do I ever leave the pole? No. So it doesn't matter what angle's there. 0 anything is the pole. 0 pi over 2, 0 2 pi, 0 pi over 7, anything like that. If you don't leave the pole, obviously you stay where 0 is, okay? All right, so example 3 says plot the point 3, negative 3 pi over 4, and find 3 additionally polar representations of this point using negative 2 pi is less than theta, which is less than 2 pi. So let's start by plotting it first. What quadrant is negative 3 pi over 4 in? Quadrant 3. And I'm on the third, 1, 2, 3, third ring. So there's my original point. You with me so far? Yes? Sure. Now I need to find another name for this same angle. So my first option is to keep R as 3. I don't want to change it. And then take my angle, negative 3 pi over 2, and add 2 pi, which becomes 8 pi over 4, and that becomes 5 pi over 4. Now the second part of this says my answer has to fall between negative 2 pi and positive 2 pi. So is negative 5 pi over 4 in between negative 2 pi and positive 2 pi? Yeah, so I get to keep it. How would I know it was too small or too big? What would be 2 pi if my denominator was 4? 8 pi. So if it's negative 8, if it's smaller than negative 8 pi, I can't keep it. 8 pi over 4. And if it's bigger than positive 8 pi over 4, I can't keep it. Okay, that's 1 of 3. So my other option is keep R the same. I added 2 pi. So what happens if I subtract 2 pi? If I subtract 8 pi over 4, what do you get? What's negative 3 pi over 4 minus 8 pi over 4? Negative 11 pi over 4. Does that fall between negative 2 pi and positive 2 pi? No, so I cannot keep it. Which means I have to go the other route. Change the sign on my R. And add and subtract what from my original angle? Pi. So I'm going to take the original angle, negative 3 pi over 4. I'm going to add pi, which becomes 4 pi over 4, and I get pi over 4. Does that fall between negative 2 pi and positive 2 pi? Yes. If I add pi to it again, if I subtract, let's do that. The other option is to subtract pi, which would be 4 pi over 4. And what do you get? Negative 7 pi over 4. Does that fall between negative 2 pi and positive 2 pi? Yes. So that's my other option. Now, if it were me, I'd double check that all of these are plotted the same spot. So if this was a test and it was multiple choice, I would actually probably just plot all 4 of my answers and see if they overlap. It's probably not going to be multiple choice, but if it was.
So you defined all 4?
Because it says 3 additional polar representations, you had to find 3. It could say 2, it could say 1. Yeah. But if I go to plot, so 5 pi over 4 and 3, 5 pi over 4, 3, that one works. The second one, pi over 4, negative 3, so pi over 4 is here. Negative 3 goes the opposite direction. That one works. And the last one, negative 7 pi over 4 and negative 3. 7 pi over 4 is here. Negative would be here. Move in the opposite direction. And that also works. So you can check all these.
So the first rule is you keep the radius the same and then you add or subtract 2 pi.
Yep, you're finding coterminals. Yep. And then the other one, change the sign, add and subtract pi. Or odd multiples of pi. You could add pi. You could add 3 pi. But most likely they're going to get to be too big. Yep. They will usually give you that it has to fall between. If it says it has to fall between 0 and 2 pi, then usually there's only like maybe one other representation of that same angle. Or 2, really 2. All right, coordinate conversion. So now we're going to talk about how do I go from polar to rectangular and rectangular to polar. If I took any of those polar coordinate grids and I also overlapped it with an XY axis, those coordinate points will have an XY coordinate. We're going to figure out how to get from one to the other, okay? The first is to go from rectangular, well, first is going to go from polar to rectangular. Honestly, the top is just an explanation, and I think it's kind of more confusing than the bottom. I would go to the bottom. It explains why this exists, but the bottom is the equation. So if I'm going from polar to rectangular, which means I'm going from r, oh, that's terrible color, r theta to xy. Then I do the radius times the cosine of theta, because think cosine is the horizontal change, which is your x, right? And then the y is r times the sine of theta. So written together in one like parentheses is like this: r cosine theta, comma, r sine theta. So what you'll get given is the radius and the theta. You'll plug those two values in. It'll be something like 2 cosine of pi over 3 and 2 sine pi over 3. And then you'll actually remember your sine and cosine at that coordinate point, and you'll plug it in. So we're bringing back the coordinates from your unit circle. The second method is rectangular to polar. Actually, let's practice the this just says to make sure that when you're showing your answer, you tell it what it is. So if my answer is supposed to be a rectangular coordinate, then I have to write x, y equals, and then like, I don't know, 3, negative 3, something like that. The reason is because there are some that are obviously an angle, like a pi over 3 is obviously an angle. But then there are some that are not. 0 is also an angle. So how do you know if it's rectangular or polar? You tell it by that. So if your answer is supposed to be in rectangular, I write it like that: x comma theta equals, and then the 2 coordinate points. If my if my answer is supposed to be r theta, then I would write r theta equals 3 comma pi over 6, something like that. So you'll tell it what it is. All right, so we're going to do these. These are polar to rectangular, and then we'll go back to rectangular polar. So convert the point 2 pi to rectangular. This is my r, this is my theta. So my coordinate would be 2 cosine pi, comma, 2 sine pi. Picture your unit circle. Pi is on the left. What's the coordinate point on the left?
1, 0.
Close. You went left, right?
Oh, negative 1.
Negative 1, 0. Good. So which part of that is the cosine? The negative 1. Which part of that's the sine? 0. So my answer is negative 2, 0. And I would say x comma y equals negative 2 theta, so that you know that that is rectangular, not polar. Now if I had crossed the polar coordinate grid in a unit circle, in a rectangular coordinate grid, it should make sense. If it was pi and 2, I'd go to pi. I'd go to this second ring and plot that point. And if this was a rectangular coordinate grid, I would just go left 2 and not up or down at all. So they should fall in the same spot. All right, go to B. Convert root 3 pi over 6 to rectangular. So I'm going to do root 3 times the cosine of pi over 6 and root 3 times the sine of pi over 6. Do you remember your coordinate at pi over 6? Root 3 over 2 and 1/2. So if unit circle has gone from your memory, you need to bring it back. Okay. So the x is your cosine, which means root 3 over 2. And the y is your sine, which means 1/2. And then what's root 3 times root 3? 3 over 2 and root 3 over 2. Because we want to know that this is an xy. This one's a little bit more obvious, but I would write xy equals 3/2 and root 3 over 2.
That's good. So
Mm-hmm.
for like finding other.
Okay, now we're gonna do rectangular to polar. So if you're given rectangular to polar, there are two parts. This to me it's super confusing if you don't listen and you don't understand what's happening. But once you understand what's happening, it should eliminate a lot of the confusion. First of all, the first thing you find is easy, and that's the radius. The radius is the square root of x squared plus y squared. Hopefully that part's easy. You just have to remember the formula, but that's the first part. Now the second part, think about what coordinates you have. You have an x coordinate and you have a y coordinate, right? So if I had plotted, for example, 3, 3, I would have gone to the right 3, I would have gone up 3, and my coordinate point is there. Now this directly overlaps with your right triangle trig. If I close this in, this is 3 and this is 3. And I want to find theta, that little angle that's there. In respect to that little angle, 3 is where? This 3 is where? Opposite. This 3 is where? Adjacent. What trig function uses opposite and adjacent? Tangent. So I would say the tangent of an angle is 3 over 3. And I would get the tangent of an angle is 1. And this is where your tangents come back into play. Which angles have a tangent? That's 1. Do you remember? It's been so very long. Over 4. So theta is pi over 4. Now I would get the exact same answer if I had -3 and -3, right? Because I'm moving left and down. Theta goes here. -3, -3. Tan of theta is -3 over -3. Tan of theta is 1 again. But there is only one right answer, and it is based on where the original point would live. So if my question was 3, 3, what quadrant is that? Top right, first quadrant. So of my over 4s, and I would have 2, I would pick the one in the first quadrant, which would be pi over 4. If you're half asleep, God help you on this one. All right. So the second part of this is that the tan of theta equals y over x. I put y over x, I simplify it. Without a calculator, there are only 5 options. Tangent is either 0, undefined, or at the over 6, it's root 3 over 3. At the over 4, it's 1, and at the over 3, it's root 3. Now I can change the signs on those middle 3. I can make it negative root 3 over 3, -1, and negative root 3. But without a calculator, it's only going to be one of those 5 values. And then you would pick where, based on where the original point is. And from there, you'll have your r and your theta. All right. This time we're going from xy to r theta. So for me, I start by plotting it because it will remind me that there's only one right answer. Where does 2, 2 live? First quadrant. So when I go to find these angles, I know I'm only picking from the first quadrant angles. Then I'm going to find r. R equals the square root of 2 squared plus 2 squared. Square root of 4 plus 4. Square root of 8, which is 2 root 2. That's first part is the r. Second part is theta. The tan of theta equals y over x. Tan of theta equals 1. I want to pull from the angles in the first quadrant. So which angle in the first quadrant has a tan of 1? Pi over 4. So my answer is r comma theta equals 2 root 2 pi over 4. Go to B, convert the point -1 to 0. Where's -1, 0?
Yeah.
On the x-axis to the left of my origin, right? That's where -1, 0 is. What angle is there? Pi. You don't even have to do the work if you understand what you're looking at, right? And what would be the radius if I only went out 1 unit? 1. If you don't see it, r equals the square root of negative 1 squared plus 0 squared, square root of 1, which is 1. There's my r. And tan theta equals 0 over negative 1. Tan theta equals 0. So what angle on the left-hand side of your graph has a tangent that's 0? Pi. So any like quadrant angle, you actually don't have to do the work if you understand what you're doing. Obviously, if you don't understand it, then you have to go through the steps. Questions? All right, now take out your calculators. All right, so first thing is we're changing our mode again. We're going from parametric, now we're into polar. So the first thing you're gonna do is you're gonna go to mode and you're gonna change it to polar. So if you were here yesterday, we changed it to parametric, now we're changing it to polar. We do polar in radians instead of degrees, okay? And think about every angle we just talked about was in pi over 6, pi over 2, whatever, all of that was radians. So you wanna make sure you're in polar and radians. Okay, next thing we're gonna do is convert. Now, it says convert the point 2.5, 1.58 to rectangular coordinates. This is when it's really hard to tell if this is in radians or, if this is in polar or rectangular, because they're gonna be decimals, not necessarily have pi in them, so be careful. Pay attention to what it's saying. It's saying we're going to rectangular. That means this is polar, and I wanna go to rectangular. Now, there's two ways to do this. The long way, if you don't know how to work your calculator, is to do what we've been doing. I would make r times cosine 2.5 and r times, well, r, which would be 2.5. Sorry, 2.5 times the cosine of 1.58 and 2.5 times the sine of 1.58. This one honestly doesn't take that much longer. If I'm going to type them in individually, I get 2.5 cosine 1.58, hit enter, and I get negative 0.023. And then 2.5 times the sine of 1.58. And I get 2.49998, so that's going to round to 2.500. And I have to say what this is. We went to rectangular, so this is XY. You with me so far? Okay, the other method, and really I would say for the rectangular to polar, it's better. It saves you more time, but this can also help, okay? The other method is this. So, in my angle menu, second apps, there is a button at the bottom, 5, 6, 7, and 8. Say R to PR, R to P theta, P to RX, and P to RY. So what it's telling you is I'm going to convert whatever you plug in here into what follows. So if I am going to rectangular, I'm starting with polar. So I'm going to go to 7. Polar to rectangular, the X. And I'm going to type in what my original coordinate point is. 2.5, comma, the comma is next to the parentheses, comma, 1.58. And I'm going to hit enter. And there's the X coordinate of my rectangular coordinate. And then I'm going to go back. Second apps. This time I'm going polar to rectangular Y. Type in the same coordinate point, 2.5, comma, 1.58. Hit enter. And there's the Y coordinate of my rectangular coordinate. While we're here, I'm going to do the next one, okay? Oh, no, the next one now says convert from this 6, 9 to polar coordinates. That means it started rectangular and it's going to polar. So the long way is the square root of x squared plus y squared. That's going to give you your r. And then do tan negative 1 of 9 over 6. The shortcut is these little buttons. So I'm going now second, apps, rectangular to polar r first, 6, comma, 9. So my r is 10.817. And then do it again, second, apps, r to p theta, 6, comma, 9. And there's theta, 0.983. So my R theta is 10.817, comma, 0.983. I would especially say to use it for that one, for the one we're converting from rectangular to polar, because the signs get tricky. If it is, let's say it's -6, comma 9, and I do second tan 9 divided by 6, I get theta equals 0.983. And if you remember your reference angles, this is 0, this is 3.14. So 0.983 radians, oh, I didn't make it negative, sorry, hang on. Second tan 9 divided by -6 gives you -9.83, which is actually in the fourth quadrant. But this this coordinate point is in which quadrant? -6, +9 puts you what quadrant? Second. So when it starts to change your signs here, you have to be careful, and my advice is to use your shortcut keys. Otherwise, you have to bring back in your reference angles. I have to know that that 0.98 has to come off of the 3.14. It's super confusing, okay? So I would say just stick with the shortcuts. These doesn't really matter. They're both about the same amount of work. But rectangular to polar, definitely use your shortcut keys on your calculator.